Hey guys, good afternoon. Just want to talk about the section 5.4. Again, this one is just part one, like what we did for 5.3. So I want to break it apart to two different sections there. So let's talk about the pairing graph of tangent and cotangent, and also the pairing graph of secant and cosecant on this video. And then for the next video, it's going to be the practice, the examples regarding the ultimate form, the standard form, or the alternate form. Okay, so we'll take a look at that, the parent graph of tangent and cotangent first. So let's say we have y equals tangent of x. Again, I want to set up the chart or the table, the xy chart. So let's say x, so we started with 0 first, and then the next one, pi over 4, pi over 2, and then over here, so let's make it symmetrical, so negative pi over 2, and then negative pi over 4. So back to the unit circle, so tangent of 0, so that's considered sine over cosine, so sine of 0 over cosine of 0, that's nothing, so that's 0. And then tangent of pi over 4, so that's sine of pi over 4 over cosine of pi over 4, which is root 2 over 2 divided by root 2 over 2, and which is 1. And then tangent of pi over 2, so sine of pi over 2, since we do know that it's 1, but for cosine of pi over 2, cosine of pi over 2, it's also 0, well, that one is 0. So that means it's 1 over 0. So 1 over 0, that's considered undefined. Okay, so that one is undefined. And then for sine of negative pi over 2, well, for tangent of negative pi over 2, so that one is also considered undefined because that one is negative 1 over 0. And then for negative pi over 2, no, negative pi over 4, excuse me. So for tangent of negative pi over 4, so then that would be considered negative 1. So with the xy coordinates, so we can just plot the points. So we got 0, 0. And then pi over 4, we do have 1. Okay, let's say 1 is up here. And then pi over 2, it's being undefined. If that's undefined, that means the graph it shows the vertical asymptote. Okay, so let's put in the vertical asymptote at pi over 2. Okay, just make it straight like that. Okay, and then what else? And negative pi over 2 is also considered undefined. So over here, it's another vertical asymptote. And then a negative pi over 2, well, that's the vertical asymptote. And negative pi over 4, then that's negative 1. So negative 1, so that's all the way down here. So once you see those three dots, so you don't want to connect them with a straight line. It's not straight, it's a curve. So this one's kind of like a cubic curve, like this. Let's just make it better. Okay, so this one is getting closer and closer to the asymptote. And this one is getting closer and closer to the vertical asymptote. So basically the tangent curve, the parent graph, it looks like the cubic curve, but it's being bounded by the vertical asymptote, negative pi over 2 and positive pi over 2. So by the time you're doing the one cycle test for tangent, you can always put in negative pi over 2 less than or equal to the quantity in the middle, and it's less than or equal to pi over 2. Okay, so let's just make it bigger. Okay, so the table, xy table, and then we just plot the point. So this one is for tangent. And now, what about for cotangent? So cotangent is quite similar to this one. So we do know that cotangent, that consists with cosine of x over sine of x. Again, I need the xy table. Okay, excuse me. Okay, so let's start it with 0. Cotangent of 0, we do know that it's considered undefined because that cosine of 0, it's 1, but sine of 0 is nothing. So it's 1 over 0, which is undefined. And then the next position, let's put in pi over 4. So cotangent of pi over 4, we do know that it's 1. Same as tangent of pi over 4. And then the next position, we do have pi over 2. So cotangent of pi over 2, which is 0, because cosine of pi over 2 is 0. And then sine of pi over 2 is 1, so 0 over 1, so 0. And then the next one, which is 3 pi over 4. So cotangent of 3 pi over 4, we do have negative 1. And then pi, cotangent of pi, so cosine of pi, it's negative 1, but sine of pi, it's 0. So negative 1 over 0, which is another undefined position. So now, let's just plug in those number and the position with the vertical asymptote. So that means at 0, we do have a first vertical asymptote. So I need the dotted line once again. So right here, so that's the vertical asymptote. And then another vertical asymptote we have is at pi. So here's pi. And then at pi over 2, cotangent of pi over 2, which is 0. And then cotangent of pi over 4, that's 1. Right up here. Okay, down here is negative 1. And then cotangent of 3 pi over 4, we do have negative 1 right here. Again, so it's a cubic curve, but it's a reflected cubic curve. So simply connect those dots. Okay. So again, this one, it just shows the apparent graph of cotangent and tangent. And for those you might be wondering, what about if I try to do the one cycle test for cotangent? So this one, as you can see, that is bounded from 0 to pi. So that means the one cycle test for this. So it's from 0 to pi. And now let me fix the one for tangents. So the boundary, this one, negative pi over 2, they're not included. So that means this one's supposed to be less than and less than. Again, that one is for the one cycle test for tangent. Okay, one cycle test. So now, for those students might be wondering, what about for the parent graph of secant and cosecant? Okay, so we'll take a look at that in just a second. Okay, so let me just clear all the notation. Yeah, perhaps I should start it with the graph paper again. Okay, so just give me 1 sec. Okay, so now what about for the parent graph of secant and cosecant? So one thing that we notice for y equals secant of x. So secant is just the reciprocal function of just the reciprocal function of cosine. So basically we can just start with the parent graph of cosine. And you may recognize the parent graph of cosine already. So that one, it's an upside down bell curve. Okay. So let me just put up the scale here for the amplitude. So this one is 1. Okay, let's see. So right here, that's 1. Down here, that's negative 1. So for the bell curve, so it started at 1. And then at pi over 2, it goes to 0. Pi, it goes all the way down to negative 1. Again, this one is just a parent graph of cosine. 3 pi over 2, so that's 0. And then 2 pi goes all the way up to 1. So since this one is just the parent graph of cosine, so I'm going to use the dotted curve. Okay. So it's all dotted. Yeah, something wrong with the pen today. Okay, like that. And now what happened at the zeros for the secant? So see that at power 2? So if that's 0 for cosine, so 1 over 0, then that'll be considered undefined. If that's undefined, so that means it's a VA, so it's a vertical asymptote. So we need to set up the vertical asymptote for that position there. Okay, so this one's a VA. And then another vertical asymptote, that's at 3 power 2. Again, if cosine is 0 at that position, that means for secant, it must be considered undefined. And now you can see that the max, the min, the amplitude. So anytime they see the max, the min right there, so that means we can start it with those points as the vertex for the parabola. Again, secant is just the reciprocal graph, the reciprocal functions of cosine. So let's just make the parabola. So let's sketch the parabola for this. Okay, let's use pink. Okay, so that means like this. That's just halfway parabola. And this one's a one full parabola. Okay, let's just fix this. And here's another parabola. Okay, so let me fix that part too. It's very difficult to trace with the sketch pad like this. Okay. So this one's supposed to be symmetrical. So you can see that secant, it's just considered an even function because that is symmetrical. If you try to continue with the rest of this, so this one is another half parabola, and then another VA over here, negative power 2. But again, we just need one full cycle, so that's the one. Now, what about for cosecant? So how do you sketch the graph, the parent graph of cosecant? Okay, well, let's continue with this one first. So what about the parent, the one cycle test? In order to do the one cycle test for secant, so this one, it goes all the way from 0 to 2 pi. So again, the one cycle test for this. So it's from 0 to 2 pi. They're both included. But right here in the VA, make sure that you need to put in that the vertical asymptote. So we'll talk about that on the next video, the way to determine the VA and also the endpoints for the one cycle test. And then what about for cosecant? So now take a look at that for cosecant down the bottom. So let's say that we do have y equals cosecant of x. So we do know that cosecant is 1 over sine of x. So that means we need to sketch the graph for the parent function of sine of x. So sine of x is a roller coaster, so that means you start at 0. And then at power 2, it goes all the way up to 1. And then pi, it goes down to 0. 3 power 2, it goes all the way down to negative 1. And then 2 pi, it goes back to 0. Again, this one is just the parent graph. Again, it's the same kind of approach like what I did with the parent graph of secant. So you need to sketch the reciprocal function graph first, which is sine for cosecant. And now at the zeros, again, we do have the VA. So let's put in the VA. So here's one. Here's another one. And here's the third one. So once again, at the max and the min, so we can just sketch the parabola. And for those of you that might be wondering how wide the parabola is going to be, it's just like a normal curve, normal parabola, because this one shows the boundary of the parabola, the VA. So let's just sketch the normal parabola. And this one's supposed to be touching because that's the vertex. And down here, same thing. And this one's supposed to be a little bit wider on the other side. Okay, so this one would be the parent graph of cosecant. So now, what about the one cycle test for cosecant? The way to do the one cycle test for cosecant, so this one it goes from 0 to 2 pi. Okay, so 0 to 2 pi. We don't include that 0 and 2 pi because those are the vertical asymptote, and also the midpoint right in between. We don't include that. Okay, so got to be careful with the way to put in the one cycle test. So once we need to do the phase shift, the find a different period. So always doing like this. Okay, so now for the next video, I'm going to be making another one. So, but that one is regarding the practice problem. So I'm going to demonstrate some of the example there. So again, this one is just the parent graph of secant, cosecant, and the previous one that I show you, tangent and cotangent. And thank you for watching the video today, and see you next time.